Hello, in this video we're going to calculate the slope of a tangent line and the equation of a tangent line in MATLAB. We're also going to find the derivative first before doing that. So what I have opened here is this is the derivative as a function section of my calculus book. We are going to be looking at example 2 here. Is going to ask us find the derivative of f of x equals square root of x for x greater than 0, and then find the tangent line to the curve at x equals 4. So the way they solve this is first for part A they take the derivative. They find the derivative, which is 1 over 2 square root of x. So in our code in MATLAB, we can do this in one go. We can one step will find the derivative for us. For part B, looks like they plug in x equals 4 into the derivative function. So they get 1/4, so that's m, or the slope. And then after that, they use point slope form. This is point slope form. They move this 2 over, so it became y-intercept form, to find the slope to find the equation of the tangent line at that point. So this is their answer: y equals 1/4 x plus 1. And they also have a graph here. It's a nice graph. It shows both functions, the point, and so on. So we're going to also make this graph in our code. All right, let's go ahead and jump over to MATLAB. So I've already put in a lot of stuff here. I've put the problem in there, the given problem. So this was example 2 in our book. We're also going to be looking at a couple of different problems in the textbook, as they are work problems in the homework or work section, number 15 and 16. But for example 2, we're going to do that first. I've already put in there, commented what it is, and we closed and cleared the workspace and so on. We're also doing this symbolically, of course, so we only need x as a symbolic variable. So let's go ahead and start. We're going to first of all take the derivative of the function. So we say df equals diff f. So this will take the derivative for us. Next, I'm going to find the slope. So m equals subs. I'm going to substitute in df and x1. So this will find the slope for us. If you recall, the slope of a tangent line is that point evaluated into the derivative. All right. Next, I'm going to find the value of y1 that we'll need for the equation of the tangent line. So we'll say y1 equals subs f comma x1. All right. So the last thing we need here is y equals m, or times x minus x1 plus y1. Because this is the point slope form of a line, we have y minus y1 equals mx minus x1, but I move this y1 over to the other side because in MATLAB and maybe other programming languages, it's conventional to only have one variable at a side. So y equals stuff. Okay, so let's see. Let's go ahead and run this. So let me go ahead and, I've already saved it and called it tangent line. That's the name of the function. So we get y equals x over 4 plus 1. That's the equation of our tangent line. And we can also do a nice fprintf command. So we say fprintf, and we will put in some things here. So we say the slope of the tangent line to the curve f equals %s at the point, and we're also going to put this in, we're going to format this. So percent %d and %d here. All right. So at that point is y equals %s and backslash n. So I can get out of here and do f x1 y1 and y. All right, let's go ahead and run what we have. We will also fix this to be in 2 lines of code so we can read all of it at once. So it says the slope of the tangent line to the curve f equals square root of x at the point 4, 2 is y equals x over 4 plus 1. So to do this nicely, we can do this like this. We put parentheses like that, and we come all the way, let's see, I can, yeah, or, sorry. So let's put a comma here, and then at the point there is, and then we put a closing parentheses like this, and let's see if we run it. We get the same fprintf command. So this one we can read better. Okay, so that's how we find the slope of a tangent line. So let's go ahead and graph now. So we'll go ahead and start graphing. All right, so this is the graph of our function here. It's similar to his graph. We can make this a little bigger. We have the slope of the tangent at the point 4, 2, and we also have the curve and the tangent line together, and we have a legend. And let's go check to see. Yeah, it's very similar to his. He labeled the graphs, but I'm not sure how to do that in MATLAB. Like, we have labeled our graphs within the graph, but that's all our graph is missing, except that it does have a let me go back to it. It does have a legend, so it'll tell us which one is which. All right, so let's put this away for now. So I can now go look at the other problems. Let me comment this, uncomment this one, and see what we get if we run it. So this is problem 15 of our book. This is the answer, the graph for it, and it also gives us the tangent line. The slope of the tangent line at that point is y equals 5x plus 3. Okay, so we can make this bigger if we'd like. And this is problem number 15, I believe, here. Let's see. This is, yeah, problem number 15, and this is this problem here. They call it S here, but in MATLAB I just call them X and Y. And let's look at number 16. Y equals x plus 3 over 1 minus x, evaluated at x equals minus 2. And the layout of this problem is similar to the example. It says differentiate the function and find the slope of the tangent line at the given value. So if we go ahead and run this one, let me comment here and run this third problem. All right, so this is at the point, let's make this bigger. So at that point, looks like 0, -2, we get that slope. And we have, this is our point here. The function is, the curve is right there, and the tangent line is it's kind of horizontal, but it's not 0. We have the value for it. It's 4x over 9 plus 11/9. That's the function and the tangent line. All right, so this is how we compute the equation of tangent lines and find the slope of tangent lines and taking derivatives. Thanks for watching.